Good day and welcome to another edition of 0 to Hero in Python Programming. I remain your host, Abbas Olayiya, and today we'll be treating reading and writing files in Python. So I'm exceptionally happy today because over the time we've been learning how to create variables, functions and the likes, and we save them within our Python script or our Jupyter notebook. But this time around, we're actually going to write a program that will help us to save files in a text file on our system instead of just writing our algorithms and just using them within our environment. So basically that's what we are going to do today. So actually to locate something, you have to know the address of that thing and the name given to that thing or the identity of that thing. So that's what we are doing in files and file path. So basically you need to know the file name and the path. So basically in Python or in any programming language, whichever file you have on your system, there are folders containing the files. So you have to be able to say, okay, go from my C drive to this particular location, then this particular location, then this particular location, then find this particular file. So that's basically what we are going to do. And to actually achieve all that, we are going to be using the OS library. And mind you, what you'll be printing out with, to locate a file on an OS X system or on a Windows system, that is, you are using a Linux system, a Mac system, or a Windows system, you are going to be getting different things. So Linux and Mac system might actually get something similar, but a Windows system will actually get something absolutely not similar to that. I'm using a Windows system right now, so what I'll be printing out will be different from what you are printing out if you are using a different system. So bear with me, and wherever you need to make corrections so that your code will be able to work on your own system, if you're not using Windows system, I will let you know. So we are going to be using the OS library, which is like the operating system library, so of Python. So now to join these parts and print them as if they are a directory on our system, so we are joining this. So what we have is this. So on Windows, we use backslash on Windows. So to locate our files on our Windows system, we use backslash. But if you are using the Linux system or the Mac system, you'll be using /. So bear that in mind. So if you are using a Windows system, you get something exactly like what I got. And if you are using a Mac or or a Linux system, you get a different variable entirely. So we want to join this with this so that it will look like we actually have this account.txt file in the Abbas folder of user in our C drive, and we have details.csv file in this. So basically, let me explain what this file stands for. So this is the file name and this is the extension. So in this video, we are actually going to be working with txt files. We are going to be producing txt files. So basically, that's what we'll be producing for our system. But if you are going to join our series, which we are starting very soon, Python, Introduction to Statistical Analysis and Machine Learning with Python and R and the science behind them, you will actually learn how to work with CSV files in Python. But here we are just going to be working with txt files in Python. So that's basically that. So the other file extensions that you are, for example, this is a document file. So it is a Word file now. So you have to open this in probably Microsoft Word or a open office project. So like that. So we are joining this our account.txt to this particular disk, so it can show the file name and the path to that particular file on our system. So that's that. So you're saying account.txt will be found in Abbas, then Abbas is found in user, and user is found on our C drive, like that for each of those files. So to get our current working directory now, so basically, for example, I'm Abbas Olayiya, I'm in Ibadan, Nigeria, Africa. So if you want to locate me in this, so probably an alien is coming to say, oh, that guy can really code and we need him on our planet. They have to come to planet Earth. Then when they get to planet Earth, they will come to Africa. From Africa, they will have to move into Nigeria. Okay, this is Nigeria. Then they will come to Ibadan. So I'm located in Ibadan. So that's how they will get my working directory. And now to actually locate me, they will have to look for my name. So which is what we are doing now. So now we are just getting the address of our file. So the address of this file I just created, that we are working with, which is reading and writing files in Python, is currently in YouTube folder. The YouTube folder is inside FibiTech folder. The FibiTech folder is inside document folder, and document folder is inside the HPMV folder, which is inside the users, which is now inside the C drive of my system. So basically, this is my user, this is my system's name, and the likes like that. So now, probably you want to change your working directory. Probably you want to import a file from another directory. into where you are working currently. So to change your working directory, you come here. So you write your C drive. If you are using a Linux system or an OS X system, you have to change these backslashes to a forward slash. So you replace these two backslash with a single forward slash. Same thing here. So I'm changing my own working directory to Windows System 32. Or if you are on a Linux system, you don't have Windows System 32. So you have to write whichever folder you want to change your working directory to. So that's that on that. So I change my working directory to Windows System 32 and I'm getting my working directory from here now. So if I run this, so this is my current working directory. So I've changed here. So I'm now checking. For example, when I checked my working directory before, I was getting this, but now I'm getting this. So now, but if you are going to change your working directory, for example, you're using a Linux system and you run this code, this will be what it will point out for you because this is not a folder on my system. So if I run this, it will give me this error and you say this system cannot find the file specified. This folder does not exist. So that's basically that on that. So I'm changing back my working directory to my exact working directory, which is the initial working directory I'm working on. So I'm changing back to my initial working directory. So I've changed back. So I get my working directory again. I get my initial working directory. So absolute path versus relative path. So absolute path, which contains the beginning of the root folder. So the absolute path will tell you from the, okay, for example, when I was describing where I stayed the other time, I said you have to come to planet 8 in the solar system, then come to Africa. So I'm telling you the specific place I'm at and how you will get there from the root folder, from getting to Earth. So that's basically what absolute path is. And relative path is just a relative path to a particular folder that you are working on. So that's that on that. So to create a new folder on your system now, so let's say you want to create a new folder, waffles, and waffles you want it to be inside the walnut folder, inside the delicious folder. So and that will be on our C drive. So basically what we are doing is, okay, all these folders does not exist on my system, but if I run this code and I go back to my system and check where my files are located, you will find out that by the time okay, let me just drag this in. So by the time I go back to my C drive now, and I will see delicious. So delicious, inside delicious folder, I have the walnuts. Inside the walnut folder, I have the waffles, and there's nothing inside it because I have not populated that folder. But so that I will prove to you that actually it's creating a folder, I will delete this delicious folder again. So after deleting that, I will now run the same code again. You will see it will create that folder for me. So that's that on that. So you can see delicious folder is created again. So walnuts and waffles. So that's that on that. So that's how to create a folder on your system. So if you are creating this folder, it will actually create the preceding folders that you told it to be inside. So that you'll be able to actually have the correct patch. But if you have the folder already and you are saying create folder, to give you this error. So mind you, that's how that works. So OS path module. So this is a module that contains many helpful functions relative to file name and file path. For instance, you've already used OS path join to build a path in a way that works on any operating system. So if you are on Linux, the directory will be different from if you are on Windows. So since OS path is a module inside OS module, you can import it by simply running import OS module. So that's that on that. So handling absolute and relative path. The OS module provides function for returning the absolute path or of a relative path, and for checking whether a given path is absolute or not. So calling OS path.absolute path will return a string of the absolute path of the argument. This is an easy way to convert a relative path to an absolute path. So calling OS path.is absolute will return true or false if the thing is in the absolute path or is not. So that's that on that. So calling os.path.real path will give you path and start. Will return a string of relative path from the starting path to the path. So basically, this is just telling you, okay, if you are saying, okay, start from so folder, so it will give you a relative path to that particular folder. So you want to get the relative path to a folder, that's the function to, so os.path does relative path. So to get absolute path from, so this the absolute path now. So this absolute path again to scripts. So now, is it absolute? False. It's not absolute because we are not giving it any path at all. So, but is this absolute? Yes, because we have located this particular file. So what this style is doing is just give me my current location, which is the YouTube. So give me my current location, and that's just relative to the current location. So if you're saying absolute, is this absolute? If you say no, because you are just telling it your current location. But if you're saying is this relative part, tell you, okay, which of this is relative part? This is relative part, whereas this is not. So relative to this place now, this folder is here. It's just the next folder after this on this Windows file. So relative to this place, this is the part to it. So this getting relative part. So another one is to get spam and egg. I mean, getting Windows relative to spam and egg. Now, if you run this, you can see Windows is telling you have to go back 2 parts before you actually come back to Windows part. So that's relative to spam and egg, like that. So get working directory. So we've done this before. So you want to get your current working directory. We check our working directory again. So calling OS part directory name part will return a string of everything that comes before the last slash in the part argument. So calling OS part does base name part will return a string of everything that comes after the last slash. So remember, base name and directory name. This one will give you everything before the slash. So will give you everything after the slash. So we have this part now. This is actually a part on a Windows system. If you are on a Linux system, you have to change this again, and same thing here and here and here. So please bear with me. So if you want to check the base name for that part, you can see that's calc.x, exe, that's a Windows file on my system. That's my calculator file on this system. Then we have the os.part.directory name for the part. So directory name is what? So this is the directory name and this is the base name. So that's like the file name and the directory to that file. So this is the directory name and this is the base name for this particular file. So this everything after the slash and this everything before the last slash. So you can see that as I explained here. So that's that on that. So another thing is calculator. Okay, this calculator file parts. So I mentioned it here. Then I said OS part of split. So I'm splitting it from, that's the file name and the part to that file. So same thing here, OS parts. So I'm now listing the OS part directory name and base name. So same thing as what I printed here, I'll do with this same function. So it's something like you writing what you can write in one line in 2 different lines and put them in a tuple again. So that's that and that. So note that os.part.split does not take a file path and return a list of string of each folder. For that to use the split string method or split on the string in the os.sep. Recall from earlier that os.sep variable is set to correct the folder separating slash for the computer running the program. So basically what that is telling us is this split here does not separate into separate files from separate parts in the tuple. But if you want to actually do that, you have to call the split on that particular file, on that particular name, not on as in you are calling it on it like you are splitting a string, not a split function, the split function in the os.part library. So that's basically that. So you remember when you did that here, we have the file name and the part, but here we splitted each in by the slash into the separate names they have. So that's basically what I was explaining here. So os.part.split, so same thing here. So this one is can't be splitted, so it's just a single variable. And mind you, this one is splitted into a list, whereas this one is splitted into a tuple. You remember when we're doing our list variable type and tuple variable type. So this list string method will work to return a list of each part of the path. It will work on any operating system if you pass it os.part.sep. So that's that. So any operating system most of the code we've written here, apart from where we're using the backslash things, it will work on any system. but where we use backslashes, you have to change them to forward slash for Linux and the likes like that. So finding file in the folder it's been contained in. So if you want to find the path to a particular file or the size of that particular file, so we found the way to get the path to the file, but now we want to find a way of getting the size of the file. So to get size, you just do the os.path.getSize. So basically that's most of the functions we are using in Python are actually intuitive. So you want to get the size, you use getSize. So basically if we run this now, you can see this is the size of my calculator .exe file. So that's 27,648 bytes. So that's that on that. So we want to print everything in that particular directory. For example, now I want to print everything in this system32 folder. Now you run this to print everything in that particular folder. So this is everything in that particular folder. You can see the calculator file is somewhere here. So you can see it's part of what is in that folder. So you can just run through that. Probably you want to check for the files in your folder before you import the file you want to use. So you can just use that function. List directory. So it will just list everything in the directory you given it, or you can just use it for your current working directory and that like that. You now want to check the size of all the files you have in the folder. So basically what we did here, we wrote a for loop that will loop through all the files in the folder. Then what it will do is we've stated total size to be 0. So it will now add total size. We replace the immediate total size with total size plus the size of the file it's checking at the moment. So it loops through all the files, check for their size, and add it to 0, which is the total file size, initial total file size. So when you now run that now, you can see it took some time to run. So I don't know how to call this now. This first 3, second 3, third 3, that's like 2 gig files, 2.008 gig of files. So let's just call it 2.009 gig of files like that. So that's that on that. But mind you, this is like 2,008,869,202 bytes of files in that particular folder. So checking path validity. Many Python functions will crash with an error if you supply them with a path that does not exist. Imagine you've written a 10,000 lines of code and you'll be running over time, and the next thing you've provided a wrong path and your code crashes. That's a bad thing, which you now have to start debugging and the like. So to actually check for path validity, so you check if the path exists. That's what you do here. So you use that one to check if the path exists. Then you check if the file actually exists, and you can check if that's actually a directory on your system. So that's that. So if you want to check if that path exists, so you check this. It's true, it exists on my system. But if you check this here, it does not exist on my system. So is directory, so we check if this is actually a directory. For example, you bring this to a Mac system or a Linux system, it will not work because it's not a directory on that system. So it will write false. So is there a file here? We didn't give it any file, so it's just a directory we give it, so it's not a file. So is this a directory? No, also, because this the directory to a file, not just a directory. So we now check if this is a file to tell us true. It's actually a file. Then you want to check if a flash drive or an external drive is plugged to your system. If you run this, to give you false. There is no external drive plugged to your system. But if I plug my flash drive now and I run this again, it will actually tell me true because a flash is now plugged to my system. So reading and writing process in Python now. So actually, we've been able to check if a file exists, the directory to a file and the likes, but we've not actually written into a file. So that's what we'll be doing from the next tutorial. So I remain your host, Abbas Olaya, and if you've not subscribed, subscribe now, and see you in the next class. Thank you.